All right, let's jump right in. We're going to tackle a massive question today using the tools of economics. Can we keep growing forever on a planet that, well, isn't getting any bigger? This is the fundamental tension at the heart of our entire civilization.
I mean, it feels like a total paradox, right? Our whole economic system is basically designed for one thing: growth. More stuff, more services, year after year. But the planet? It has limits. So what gives? Are we just speeding towards a cliff? Let's figure this out.
Okay, to really get to the bottom of this running out problem, we first have to understand how we make things in the first place. So let's strip it all down. Think of the entire global economy as having a super simple two-ingredient recipe. And here it is, the recipe for, well, everything. Q is the output, all the goods and services we create. And we make it all by mixing together just two things. K, which stands for capital. That's all our man-made stuff like factories, tools, and tech. And R for natural resources. You know, the stuff we pull out of the earth. That's it. That's the basic formula for our entire economy. Now, this is where that feeling of dread can creep in. What happens if one of those resources is essential? An essential resource is an ingredient you absolutely cannot do without. If you have zero of it, your output is zero. Production doesn't just slow down, it stops. Cold. And that is the core of the whole running out anxiety. So if we need these essential ingredients, and they can run out, are we just doomed? Well, this is where economics gives us a surprisingly powerful and kind of elegant solution. See, the secret isn't about having infinite stuff. It's about being incredibly clever with the stuff we do have. Let's talk about a secret power baked into our economy. Okay, stick with me here because this term, elasticity of substitution, sounds super academic. But the idea behind it, it's actually pretty simple. And it is the key to this whole puzzle. All it measures is our economy's flexibility. How easily can we swap one ingredient in our recipe for another? That's it. So let's look at the worst case scenario, a totally rigid economy. The elasticity here is zero. Think about a cake recipe that says you need exactly 2 eggs. If you have a mountain of flour and a ton of sugar, but you have 0 eggs, you're not making a cake, period. No swapping possible. In this world, running out of something is a genuine catastrophe. Now let's flip that completely. Imagine a perfectly flexible economy. It's like making a fruit salad. Don't have any strawberries? No problem. Toss in some raspberries. No apples? Pears will work just fine. You can always swap one thing for another to get the job done. In a world like this, scarcity isn't really a problem you worry about. So where does our real-world economy actually live? You guessed it, somewhere in the middle. We can substitute things, but it's not always a perfect one-for-one swap. We can replace old copper phone lines with fiber optic cables, or we can replace fossil fuel power plants with solar farms. This ability to swap, to be flexible, is our greatest defense against scarcity. But, you know, being flexible isn't enough. We also need some kind of signal, something that tells us when it's time to start swapping. And that signal, my friends, is price. But how on earth does a market put a price on something we might not run out of for another 100 years? It's pretty wild. It happens through this fascinating idea called the marginal user cost. The best way to think about it is like an invisible price tag that gets added to a resource as it gets scarcer. It's the cost to the future. Every time we use a barrel of non-renewable oil today, we are taking it away from our grandkids, and that loss has a value. This means the actual price of anything we pull from the ground is really made of 2 parts. You've got the marginal extraction cost. That's just the physical cost of digging it up. But then the market adds this forward-looking price, this scarcity premium, the marginal user cost. The two together make up the real price we pay. And here's the cool part. Watch what happens over time. When a resource is super abundant, that user cost is tiny, almost zero. But as we use more of it, as it gets scarcer, that user cost starts to grow and grow and grow, pushing the total price higher and higher. That rising price is the market literally screaming at us, hey, it's time to find a substitute. And that brings us to the big reveal, the climax of this economic story. That rising price, pushed up by that ever-increasing cost to the future, is what forces us to change. The amazing thing is, the economic model shows we don't just keep burning through a resource until the very last drop is gone. We're actually pushed to switch long before that happens. So how does this great resource switch actually play out? Well, it's a pretty elegant 4-step dance. Step 1, we use the cheap, easy, finite stuff. Step 2, as it gets scarcer, its price goes up. Step 3, eventually its price gets so high that it becomes just as expensive as a renewable alternative, what economists call a backstop technology, like solar or wind. And step 4, at that exact point, the market yells switch, and the whole economy starts pivoting to the new sustainable resource. Okay, so after all of that, the economic recipe, the power of swapping ingredients, the invisible price of the future, let's circle all the way back to that big, scary question we started with. Are we doomed? You know, the source material for this explainer puts it beautifully. From a purely economic point of view, the fact that a resource is finite isn't the real problem. The real challenge, the real question, is whether we are clever enough to invent and implement that reproducible substitute before the old way becomes way too expensive. So, if you're gonna remember just a few things from all this, here they are. First, our economy's flexibility, its ability to substitute, is our superpower. Second, we have to keep innovating to create those renewable backstop options to switch to. And third, prices have to tell the truth. They need to reflect future scarcity to give us that early warning signal. When all those things work together, we get a smooth, efficient transition.
But here's the thing. At the end of the day, these economic models don't predict the future. They just show us what's possible. They lay out a roadmap, a pathway where human ingenuity, smart pricing, and flexibility can let us prosper on this amazing, finite planet. The tools are there. So the question isn't really, can we build a sustainable future anymore? It's, will we?